Hi, welcome all to lecture number 5 in this lecture series on 8051. Actually, the block diagram of 8051, or it is also called architecture, is one of the main frequently asked questions in university exams. So, we will see details on the block diagram of 8051. Actually, 8051 is a microcontroller. So, it has both features of a microprocessor and some additional peripherals. So the block diagram contains two main parts. The first part is a unique feature of 8051: ROM, RAM, IO ports, then timer, counter, and serial data communication circuitry. These things are present in our 8051. Generally, they are not present in a microprocessor. So these things are unique features to 8051 microcontroller. Then we have our common stuff. Common means it's very important for functioning of a microcontroller or microprocessor, that kind of stuff. They are CPU components. They are program counter, ALU, working registers, and clock circuitry. Okay, so we will actually deal with every single block in the block diagram, but in this video we will give a overview of each and every blocks. Okay, and we will see the block diagram. So now we will see every blocks in the block diagram of 8051. So first of all, we will see the CPU related components. This is the ALU, arithmetic or logic unit. Keep in mind that ALU is 8-bit. ALU is 8-bit. This is the reason why 8051 is an 8-bit microcontroller, because ALU is 8-bit. So ALU can deal with numbers of width 8-bit. Then we have program status word. This is connected to ALU because, as the name suggests, the status of this 8 bits stored in ALU, or after the calculation we will get a result. The result generally is stored in accumulator, this register, and the result will be having some peculiar characteristics, and those characteristics are stored in this flag register or program status word. Okay, we will see this in detail again. So this is our ALU, which is 8-bit. This is our program status word, which is again 8-bit. Then we have two registers, A and B. B is a general purpose register, but A is the accumulator. This is 8-bit. B is also 8-bit. Then we have program counter and DPTR. Actually, program counter is used to store address, not data. It's used to store address of the next instruction in our program. This program counter is 16-bit. Okay. Then we have DPTR, or it's called as data pointer, which is again 16-bit. It is also used to store address. Why this is 16-bit we will see later. Okay, so these are the stuffs related to our CPU. Then we have additional or peripherals, which is unique to 8051. The first one is the internal RAM. Internal RAM is 128 byte. 1 byte is 8-bit. So we have 128 location, where each location can store 8-bit. So what is the size of our RAM? It is 128 bytes. Then we have the internal ROM. Internal ROM is actually 4K. 4K, 4 into 1024. That much location we have in our internal ROM. This internal ROM is actually used to store programs. Then coming to ports, we have 4 ports: port 0, port 1, port 2, and port 3. Each port contains 8 wires, 8 physical wires. Every port can be used as input output port. Input output, input output, input output, and input output. And some ports have some additional functions. We will see about the additional functions. Okay, so this port has additional function of carrying address and data. This port don't have any additional functions. This port has the additional function of carrying address only, not data, because data is always 8-bit. So 8-bit is already transferred to or through this port. So this port is only used for transferring the address. Then port number 3. Port number 3 has some special functions. Each pin has some special function. We will see to that special function later. Now just we will read out the names. They are interrupt, counter, serial data, and read or write. So here 8 into 4, 32 pins. 32 pins in the IC package are given for ports. So actually the 8051 is a 40 pin IC. In 40 pins, 32 pin are given to these ports. Then rest of the pins are for giving necessary signals to 8051 like VCC, ground, then clock generating, frequency generating, crystal oscillator, that kind of pins are also provided. Now coming to this block. This block is nothing but the expansion of our internal RAM. This RAM is actually expanded here. The internal RAM structure. The internal RAM contains register banks. Apart from these two registers A and B, we also have other registers, and registers are named as R0 to R7. So each bank will be having 8 registers, R0 to R7. We can select any of this bank in our program. By default, this bank is selected. Then we have byte or bit addressable areas. Then we have special function registers. These are needed for setting different parameters inside our microcontroller, and we will see each and every special function registers later. Then actually address bus will be always 16-bit and data bus will be always 8-bit. You can notice that the address bus, this is the address bus. The address bus is only connected to this port and this port because these two ports are intended to carry address. And the data bus, this database is connected to each and every port because data can flow through each and every port. That's why. And here we have the control circuitry. The control circuitry includes system timing, system interrupt, then timers, then data buffers, memory control, that kind of stuffs are given here. So this is actually the control block. Now coming to some additional information. Actually in lab exams they will ask which port in 8051 is multiplexed port. Actually the answer is port 0 is multiplexed port because we can see that the port can carry both address and data. So it is called multiplexed port. Actually with which bits of address it carry. You can see that address is from A0 to A7. A0 to A7 means 8-bit. Then rest of the address A8 to A15 is through port 2. Actually why is that? Let's see. Actually the address range is A0 to A15. So A0 to A7 is the first 8-bit. Then A8 to A15 is a higher 8 bit. So actually we have 16 wires. In this 16 wires, this 8 wire is given to this port because each port has only 8 wires. So A0 to A7 is going through port number 0. Then the rest, that is the higher 8 bits, A8 to A15 is going through port number 2. Then data, as I have already told you, is always 8 bit, D0 to D7. So actually one port is needed to carry data. That's why this information is going through port 0 and this information is going through port 2. So then the next question comes, why address and data lines are given? We already have ROM, 4K ROM inside our 8051 microcontroller. So for any reason, if we want to connect some additional memory, or let's say this is not enough for our program, our program is actually, let's say, 32K long, so we cannot store our program in 4K ROM. In that case, we can connect some additional memory. We can connect an additional memory, additional ROM to 8051 through these pins. So maximum, how much of memory, that is maximum, how much of memory can be connected to our 8051? The answer is 64K. Because how many address lines are there? We have 16 address lines. So just 2 raised to 16. Do this. We will get 65,536. Divide it by 1024. This is 64K. If you are new to this, go and watch my memory video. I have clearly explained about the concept. Okay, so 64K is the maximum memory which can be, that is maximum external ROM which can be connected to our 8051. And our memory will be having database and address bus. The address bus is 16-bit wide and database is 8-bit wide. That's why additional address and data lines are given here, because we can connect external memory if needed. Apart from external ROM, external RAM can also be connected with 8051. We will see to it later. Now coming to functions of these pins. EA is external access. This bar indicate it is active low pin. Active low means this signal is activated when we give 0 to this pin. ALE is address latch enable, which is active low because no bar is there. Sorry, active high because bar is not there. Then PSEN means program store enable. In normal condition, these 3 pins are not used. By normal I mean if we are using this internal RAM and ROM, that is we are not going for any external memory, then these pins are not used. These pins are only used when we are connecting some external memory to 8051. And extal 1 and extal 2 is used to connect the crystal needed to generate the clock signal or the timing constraint of our 8051. Then reset is for resetting our chip. Then VCC and ground. VCC is generally 5 volt and ground. These are the input supply voltages. So this is actually the overview of 8051 block diagram.